Okay, we're going to take a look at section 8.3, calculating the present value. So this is a compound interest problem, and again we have very similar setup to what we had with simple interest, where we have some maturity value in the future, or future value, and a present value in the past. And what we want to do is we want to convert that future value, discount it into the past to compute a present value. So again, this is called discounting a payment, and the rate that we'd use is a discount rate. It's not an amount that we're earning, but we're going to discount it, so we want to figure out how much discount we need on our future value to be a present value in the past. We had a formula before that said our future value is equal to our present value 1 plus I to the n. So simply that is, if we want to calculate a present value, it's the future value divided by 1 plus I to the n. So jumping right in, we'll do a problem that says we'll do question 6 on page 292. So page 292, number 6, it says what principal amount will have the maturity value of 5437.52 after 27 months if it earns 8.5% compounded quarterly. So again, we start with our problem and we say, well, we have a future value of 5437.52. We have a duration of 27 months. And we know that money earns 8.5% quarterly. What we're looking at is we want to know how much money should we have here. So we have to take our future value, we have to discount it, move it into the past, and calculate a present value. Again, most of the work here is calculating I and calculating n. So we say I is equal to j over m. This is our nominal rate of 8.5% over how many times per year? Well, quarterly is 4 times per year. 8.5 divided by 4, 2.125%. Second we calculate is our n, and our n is equal to number of years. Well, how many years do we have here? Well, I'm too lazy to figure that out, but I know this is 27 months over 12 months per year, compared to 4 times that I'm compounding per year. Again, this m has to match that m. So the m that we deal with for I is the same as the m we deal with for n, because we know that n is equal to years times the compoundings per year. Well, just computing this, we say this is 27 divided by 12. Oh yeah, it's 2.25 years times 4. Well, that's going to be 9 periods. 9 compoundings. So we're going to earn 2.125% each compounding for 9 compoundings. So if we take a look, there's going to be 9 periods in here, and each time we're going to get interest on interest. So future value is present value 1 plus I to the n. So our present value is our future value divided by 1 plus I to the n. This is equal to, well, our future value was 5437.52 divided by 1 plus I, 0.02125. And the n is 9 compounding, so the exponent 9. So we're looking at, do the calculation, 5437.2, sorry, 0.52, divided by 1 plus 0.02125, the exponent 9, $4,499.997, $4,500. Now again, we want the calculator to do the work. So ignore the formula and we just do the stuff that we did before. Calculator I, calculator N. We say our our future value was 5437.52. And if you take a look at the problem and say, what principal amount will have the maturity value? Well, do we know if we're getting paid or not? Well, we don't. So I'm going to make that positive. I'm going to say I want to get paid $5,437.52 in the future. And this is going to be 27 over 12, number of years, times 4, and that was 9. Yeah, per y, this is going to be equal to our 8.5%, divided by 4, which is equal to 2.125. And we're going to compute the present value to be, well, let's put all this in. 5432.52 future value. We're going to say our 27 divided by 12 times 4, 27 divided by 12 times 4 is 9n. And 8.5, again, I put percentages in the calculator, divided by 4, 2.125%. We're going to compute the present value to be, it's going to say it's negative 4495.86. That doesn't seem right. I'm going to recall the future value. I realize that my calculator had the wrong value here in future value. I can say recall future value and see that everything's right. N was right. I was right. Future value is wrong. So I'm going to put in 5737.52. That is my future value. And now I'm going to compute the present value to be negative 499.997, which rounds up to 4,500. And this was negative. Now we'll talk about the cash flow convention. So this was a negative value and this was positive. If I did it the other way around, if I put in 5437.52 as a negative value, and then I computed the present value, it would be a positive value. So we'll talk about the cash flow convention. So financial calculator, cash flow convention. And what this says is amounts that are paid to you are positive. It's an amount that you get. That's a positive amount. Amounts that you have to pay are negative. Okay, these are negative. These are amounts you have to pay, negative amount. It's money leaving to you. So positive, this is money coming to you. And negative, money going away from you. So in our cash flow convention, in our last example, if we had a positive future value, that meant a negative present value. Also, if we had a negative future value, it meant a positive present value. It's more of something where we're finding out the amount that we have to pay or the amount to receive in case something else happens, because we may make some extra payments and have a value at the end. It's something that isn't going to matter too much until we look at chapter 10, but it's just something where you get a negative value out. It's not an important it's not an important aspect in chapter 8, but it will be as we go on in the course. So cash flow convention.